Let's say we had test scores where the mean was 80 and the standard deviation was 10. I know a mean of 80 is a little low. I'm using 80 just because the arithmetic is nice. And we wanted to know what proportion of the scores, if the scores are normally distributed, would lie between two boundaries. We can use NormalCDF. It's asking for the lower bound, upper bound, the mean, and the standard deviation. So let's say we wanted to know what proportion lied between a 70 and a 90. Now we know from previous work that that's one standard deviation below the mean and one standard deviation above the mean. The mean is 80 and the standard deviation is 10. So because we want to know what proportion of the data falls within one standard deviation of the mean, we're expecting to be about 68%. And that's right. We get about 68%. Now let's do this again. And say what proportion of the data lies, let's say, above 80%. So that would make the lower bound 80. And the upper bound is actually infinity. The largest number on the calculator is 1 times 10 to the 99th. So we type in 1 second EE here. Shows up as 1E there, 99. So we want to know what proportion of the data is between the lower bound of 80 and the upper bound of as close as we can get to infinity, keeping the mean at 80 and the standard deviation at 10. So that's half of the data, so we're expecting about 50%. So we paste it into the home screen and hit enter, and indeed we get something very close to 50% with a tiny little bit of round off error. That's how you use normal CDF.